Hello and welcome to the UK CANSAT competition. This is our presentation of our team and our objectives. And more content can be found on our YouTube channel. So click subscribe, I guess, if you need some advice on how to get started with CANSAT. So what is CANSAT? CANSAT is a competition which requires you to build a satellite which can take measurements such as temperature, altitude, and pressure, which you launch to an altitude to 300 meters and try and land safely and record what you can. Your main objective is, of course, to take the pressure, altitude, and temperature as you come down, and you get to choose a secondary objective, which can be whatever you like within reason to try and achieve in some way as the satellite is falling down or after it hits the ground. Usually based on science, some form of scientific measurement or hypothesis. We chose our secondary objective to be searching for conditions in which we could create life, so we could we could start agriculture and plant stuff to possibly sustain life on another planet. And this was like a design of how to do that. Our mission, so I've already explained the first objective we have, which is just to measure temperature, pressure, and altitude on the way down. And our secondary objective, which I touched briefly on earlier, looks at a key part of determining whether a planet which our satellite could be sent to could sustain human life. So if the terrain and atmosphere was suitable for agriculture. And in order to do this, we decided to look at key ingredients that a planet would need to allow photosynthesis, which is the primary way that plants would be able to grow and would be key in supporting human survival on another planet. The context of our objective is mostly about Goldilocks exoplanets, so planets which could be similar to Earth, and we could explore them to see if it would be possible to sustain human life. Alpha Centauri is a famous example, and of course it's also partially inspired by the Martian movie and the book, where the main character plants potatoes on Mars in order to survive before coming back to Earth after being stranded there. We could use our determinants, so what we're measuring, to see if basic agriculture was possible just normally without having to build special enclosures and greenhouses for it, and if it would be possible we could then have a viable food source on another planet. And this is the equation for photosynthesis here. Right here. Now, the measurements that we took are based... There are 3 key measurements to take as part of our secondary objective. And we decided these to be light intensity. So, because plants can't grow without light. CO2, because if a plant doesn't have CO2, they can't perform photosynthesis. And soil moisture, because it ensures that plants can remain turgid with their cells and make sure that some of their cellular reactions can occur. Water is also a key reactant in photosynthesis, and also just life in general tends to be found where there is water. So for the primary objective, we will measure how temperature and air pressure change with altitude. This is what I mentioned earlier. We have to record it at a frequency of 1 hertz, so once every second, according to the CANSAT guidelines. And for the secondary objective, we are going to be using an Arduino Nano, more specifically a BLE Sense, in which has the sensors already inbuilt, which allows us to use less circuitry, which means less could go wrong, and it's more compact. It has, and as mentioned here, it has an inbuilt lux meter, which can be used to take light intensity readings. CO2 readings are using a Adafruit breakout sensor, and they are recorded and transmitted to ground control using a radio transmitter, and soil moisture readings will be taken, as it says here, after our CANSAT lands, and a moisture sensor will be driven into the ground using a motor, and readings will then be taken and transmitted. Our analysis is also a very important part, where we will analyze the measurements of how our data would be represented. For the first primary objective that we have to do, we will record values of air pressure and temperature, as I've said previously mentioned, which are received from the CANSAT, and we'll plot a graph of those against altitude, so how high it is. So hopefully we'd be able to see, like, as it comes down, air pressure would increase as it comes down, and temperature would hopefully also increase because it gets warmer the closer to the ground you are. And for our secondary objective, we decided to use statistics from maths to make a null hypothesis, and our first hypothesis, and in order to reject the null hypothesis, which is that plant life could not photosynthesize at the surface of the planet that we're on, which we want to reject this, the values we obtain need to indicate this. So the soil moisture should be 20 to 60%, the light intensity should be between 15,000 and 50,000 lux, and the CO2 concentration should be around 10,000 to 1,200 parts per millimeter, and 18 to 21 degrees Celsius. These are mostly used for things like potatoes, as inspired by The Martian, which we thought was quite interesting and fun to do. If the data we collect is in these ranges, then plants could survive, and we could survive on the planet we land on. And that is, well, all our CANSAT is. That's what this competition is. It's genuinely a difficult engineering competition, and as you see, we have to fit all these sensors into this rather small can here. This is no larger than a drinks can, and it's hard to fit components, especially batteries, in this CANSAT. As well as this, we are going to also be uploading another video which will explain how you should get started with CANSAT, especially because it is hard to initially work out exactly what you want to do and how you want to perform it. And just some general advice that we have from our CANSAT experiences, I guess. This is genuinely a fun competition, and if you are able to do this, if you do fit within like the age boundaries and so on and so forth, I think that everyone should do this competition if you are interested in engineering, because it teaches you quite a bit and allows you to work in a team to pull off something that is genuinely quite impressive in recording values and building what's essentially a satellite. It's also run by the European Space Agency, which it's also quite cool. So thank you for watching, and I hope that you do look at CANSAT, because it's very cool and interesting competition. Thank you.